Good morning, class. We are looking at the sequences and difference equations, section 1.6. First, in short, a sequence is a list of numbers that is written in a specific order. We have the first one, a sub 1, the second one, a sub 2, and all the way to the general term of a sub n. A recursive sequence or a difference equation has the formula a sub n plus 1 equals f of a sub n, which means the next term depends on the previous one. That's the meaning of that. Let's look at a couple of sequences that everybody is familiar with. In algebra, we learned about arithmetic sequence and geometric sequence. When we add a constant difference, okay, or distance, it becomes an arithmetic sequence. So recursively, the next term is the previous one plus the distance or the common difference. Okay. Explicitly, a sub n is a sub 1 plus n minus 1 times t. So, example, 1 plus 4, 5 plus 4, 9 plus 4, so on and so forth. As you can see, there's a constant being added. In the case of a geometric sequence, we are multiplying by a ratio, we call it. Okay, a sub 1r, a sub 1r squared, and the general term a sub 1r to the power of n minus 1. Recursively, the next one is the previous one times r. Explicitly is a sub 1 times r to the power of n minus 1. Example, 1 times 4, 4 times 4, 16 times 4, so on and so forth. So this is a simple example of arithmetic and geometric sequence. So again, we're going to repeat the same thing that we mentioned, so I'm not going to go over that. What I want to mention is that, again, a sequence is a real valued function whose domain is a set of natural numbers. So just in case, natural numbers, we mean 1, 2, 3, all the way to the end. That's the set of natural numbers. The first term is a sub 1, the second one is a sub 2, all the way to the n. That means a sub n, the general function. Let's start with, given the general terms, we want to find the first 5. I hope you realize that n starts with 1. So a sub 1 is 1. A sub 2 is 2, so on and so forth. So we have 1, 2, 3, 4, 5. Very straightforward, class. Now I'm going to explain this one with the use of what we call a unit circle in a moment. This is a basic trigonometry. Everybody is supposed to know some basic trigonometry. I hope you remember that. First of all, b sub n is sine of n pi divided by 2. That means if n is 1, replace it with 1. Sine of pi over 2. If n is 2, 2 pi over 2. Sine of 2 pi over 2, so on and so forth. And by the way, clearly, we can see that this one is 2 pi over 2. This one is 4 pi over 2. And here's the answers. For example, sine of pi over 2 is 1. Whether you remember it or not, I don't know. But I will go over that using the unit circle in a moment. I will go over that. First, I want to finish the page. So starting with, again, another simple example, C sub n has this formula, class, meaning if I want C sub 1, I replace the n with 1. I get 1 over 1 plus 1. So again, let me just quickly write this. So if I want C sub 1 is what? 1 over 1 plus 1. Which is 1/2. Okay. So if I want C sub 2 is what? N is 2. 2/3. Okay. And so on and so forth. The next question is asking for the nth decimal place of pi. And class, I hope you remember that pi is not equal to 3.14. It is approximated by that. It is actually 3.14159, and it continues indefinitely. And therefore, when we want the nth decimal, the first one would be 1, the second one would be 4, and we can figure out the rest of it. So this is how you write, okay, the digit in the nth decimal place of pi. This is how you write that. What I like to do is to go over the concept, okay, that I just mentioned, the unit circle, okay, to remind you of how we take care of the basic ones when we have to figure out the trigonometric function and their values. Okay, class, everybody remembers unit circle, I hope. X squared plus y squared equals 1, 1, 0, 0, 1. My apologies, negative 1, 0. 0, 1. Of course, this is not to scale, class, but you get the picture, 0, negative 1. And so if you recall, we said when it comes to unit circle, if we draw this and we call this theta, then this point P has coordinates x, which is cosine theta, and y, which is sine theta. So x is being represented by cosine, y is being represented by sine, and therefore, if I'm looking at this point, the angle it makes is 0. Cosine 0 is 1. Sine 0 is 0. If I'm looking at this point, remember what this is, 90 degrees or pi over 2, cosine is 0, sine is 1. If I'm looking at this point, this is 180 degrees or pi. Cosine is negative 1, sine of pi, 0. If I'm looking at this one, this is 270 degrees or 3 pi over 2. Cosine 3 pi over 2 is 0. Sine 3 pi over 2 equals negative 1. And so we can write, generally speaking, sine of n pi is 0. Cosine of n pi changes between negative 1 and 1. Cosine of 2n plus 1 times pi over 2. This is actually, let me just make it look better. And 2n plus 1 times pi over 2, that means odd multiples of pi over 2. It's always 0. Okay, so I hope that's straightforward, and I hope that helps. So having said that, let's go back to what we were doing. And let's go look at this example. In this case, we want to find the first 5 terms again. Okay, so what is a sub 1? 2 to the power of 1. minus 4. That means 2 minus 4. That means negative 2. What is a sub 2, everybody? A sub 2 is 2 squared, which is 4 minus 4 is 0. If I want a sub 3, let me just quickly write that one also. If I want a sub 3, it's what? 2 cubed minus 4. 8 minus 4, which is 4. And those are the terms. Now, as long as you can show your work for a few of them, you can show work for all of them. It's really not a big deal, class. You show your reader that I know those two, therefore I know the rest of it. Okay. We want to find the general formula. Finding the general formula sometimes is extremely difficult. I want you to know that, class. Sometimes we have a arithmetic sequence. Sometimes we have a geometric sequence. Sometimes we have a combination. Sometimes none of the above. You have to be creative. So what happens here? 5 plus 3, 8 plus 3, 11 plus 3. We notice this is an arithmetic sequence with the distance or difference of 3. We notice that. We also have the formula a sub n is a sub 1 plus d times n minus 1. So what is a sub 1? 5. What is the difference? Common distance, 3. Plug in. Now, simplification is elementary algebra. You do that, you end up with 3n plus 2. If you write it as 2 plus 3n, it's the same thing, class. But 5 plus 3n minus 3, and 5 and negative 3 gives us 2. Now, it is extremely important that you check your work. How? If I replace the n with 1, it should give me 5. 2, 3 times 2, 6, and 2, 8, and so on and so forth. You should check at least with 3 of them, if not more, to be on the safe side. Okay. What happens next? We notice there is a trend going on. We are multiplying by negative 1/3. That means you're dealing with GS, geometric sequence, and the ratio is negative 1/3. So a sub n is a sub 1 r to the power of n minus 1. A sub 1 is 1, and r is negative 1/3. Now, what I want to explain here is that anytime, so if you plug in, you get the first one. If you plug in, you get the first one. Anytime you have a negative sign, that means you really have an alternating sequence. It changes from positive to negative or negative to positive. It doesn't matter. The negative one is involved, and we like to separate the negative one. Notice negative 1 to the power of n minus 1, and this is 1/3, and this 1 has no bearing, so this is it. So generally speaking, when it alternates, you have one of the two. Now the question is, which one and why? Well, if you look at the first one, class, if I use this one, negative 1 to the power of 1 is negative 1. That doesn't work. But if I use this one, negative 1 to the power of, the first one is, okay, 1 minus 1 gives us 0. Negative 1 to the power of 0 is positive, so that works. So this is the one. That's the reason I mentioned that sometimes it's not this simple. So you separate the negative sign and then you move on. Of course, if by any chance you wrote this as negative 1 to the power of n plus 1, it gives you the same result, okay? Either way, if you see it that. All right, again, sequences are sometimes created recursively, specifying the next term given the present term. We've been discussing that, okay? This procedure defines each new term as a function of the previous one. So what are we talking about? Again, this very important definition that was discussed. A difference equation or recursive sequence is an equation of the form a sub n plus 1 is f of a sub n, where a sub 1 is given and f is a real valued function. Okay, so you need some sort of a previous term like a sub 1. A solution is, of course, you write it out, a sub 1, a sub 2, a sub 3, and they should work, and they should fit the description that is given here. Have we seen any recursive sequence, any difference equation in the past? Yes, a very famous one is called Fibonacci sequence. I hope everybody remembers that. Okay, so for example, here, it says f sub n is f sub n minus 1 plus f sub n minus 2, meaning if I want to create any term, I need the previous one and the one before that. That's really the meaning of it, with the exception of the first two. That's why it says n larger than or equal to 3. So the first one is 1, the second one is 1. What happens to this one? 1 plus 1 is 2. 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8. 5 plus 8 is 13, 8 plus 13 is 21. Can anybody give me the next term? What would be the next term? Anyone? The next one would be 13 plus 21, which is 34, so on and so forth. And in the example, in nature, the number of branches increases up a tree trunk, okay, following the Fibonacci sequence class. So here's a few interesting examples we want to look at. A sub 1 is 6, a sub n plus 1 is a sub n over n. It's important to write the formula. So I have a sub 1, the next one is a sub 2. So change this to a sub 2. So I want to make sure we understand what's happening. Now I need a sub 2. Okay, according to this formula, it says a sub, the next one is the previous one divided by n, right? So a sub 1 divided by 1. I hope you see that. First you write the formula and then plug in 6 over 1 becomes 6. How about a sub 3? That would be a sub 2 divided by 2. So 6 divided by 2 is the answer. What about a sub 4? Is a sub 3 divided by 3. So 3 divided by 3, which is 1. And again, I highly recommend you try this on your own. Make sure you can come up with those. So here's the list. Okay. We wanted how many? The first 6. The first one was given. We added 5 more. Okay. The next part requires using the formula. The first one is given, the second one is given. Here's the formula. Now, what is the next one? We want a sub 1, we have it. We want a sub 2, we have it. Now the next one is a sub 3. So change n plus 2 to 3. If you set n plus 2 to 3, n becomes 1. So 1 and 1 is 2, so it's a sub 2 plus 2, a sub 1. Remember, n plus 2 equals 3. So I hope you see the formula. So the next one is a sub 3. And so basically what this formula says is, if I want 1, I need the previous one. See, a sub n plus 2 is a sub n plus 1, the previous one. So if I want a sub 3, I need the previous one, plus 2 times the one before this. So if this is a sub 2 plus 2 times a sub 1. So plug in, a sub 2 is given. 2, and then 2 times that, 2 times 1, and we end up with 4. Now, what is a sub 4? Okay, so just following this trend, class, just following this trend. If I were to just write it right here, a sub 4, see, a sub 3 is a sub 2 plus 2 a sub 1, so it's a sub 3 plus 2 a sub 2. Or I can say n plus 2 equals 4, and n becomes 2, and I put it into the right side, okay? Meaning I put it into this and into this to find the n, either way. And so this is the next one. And so a sub 3 is 4. Okay, let me A sub 3 is 4 plus 2 times A sub 2, 2 times A sub 2 is 2, and you end up with 8. Now, I'm going to give you the answer for the rest of it, and I highly recommend you try those and make sure you can find them. In fact, you add one more or two more. You need this practice to be on the safe side. Now, what does part C tells us? It says, if I want a term, I need 2 times the previous one minus 4. So I have A sub 1. Just as an example, the moment I look at this one, so if I want, so this is A sub 1, so I want A sub 2, right? It says A sub n plus 1 is 2 times the previous one, so I 2 times A sub 1 minus 4. I hope you realize that. Or you can say n plus 1 is a 2, and therefore n is 1. That's how you get 2 times A sub 1 in case. So you plug in 2A sub 1, so 2 times 3 minus 4 equals 2. And what is A sub 3? Now A sub 3, if you change this number to 3, you change this number to 2. That's all. So A sub 3 is 2A sub 2 minus 4. Ends up being 0. And you can do the rest of them. As long as you show 2 starting with formulas class, you can do them all. It shouldn't be a big deal at all. I hope everybody's comfortable with that. An application of this concept can be found when we deal with medications and patients. Here's an example. Suppose C sub T is the concentration of a drug in the bloodstream at time T. A is the amount of inflow, the concentration of the drug that is given to the patient, and K is the fraction that is gone. Okay, so what is the recursion formula for this? Okay, and then if the initial value is that. So I want to discuss the recursion formula for medication in general is this. So the next amount is equal to the previous one plus what we add, the inflow, and what we take out. What do we take out? Our body takes out. What does it take out? A percentage. For example, if the body takes out 80%, that means 20% of the drug is left. Okay. If it takes out 30%, that means 70% is left. In other words, this one in conjunction with this one gives us the percentage left. I can't emphasize this enough. So what I'm going to do, because it says C sub T, we're going to change this to C sub T plus 1. We're going to change this to C sub T. Inflow, we're going to change it to A. Now, outflow, if we are using K, the percentage, the fraction, okay, then K is gone. So K times N sub T, or in this case, C sub T is gone. So C sub T plus 1 is C sub T, the inflow is A. Now, how much does it take if it's the percentage or fraction times C sub T? I hope you realize that. Now I can put the first and the last together and factor out C sub T, and I get C sub T times 1 minus K. This is a simple factoring. So C sub T plus 1 is C sub T times 1 minus K. This part basically says, if 30% is gone, this is 70% of C sub T. Is if 80% is gone, 20% is left. That's the meaning of 1 minus K times C sub T. Now, if A is 80, we're going to replace it. If K is 1/2, we're going to replace it. Let's do that. So when we do that, 1 minus 1/2 happen to be 1/2 again. And so the formula is 1/2 C sub T plus 80. What it means is when we add the new amount, which is a constant 80 micrograms per milliliters of the drug. This is the constant. Half of what was in there is left. Okay, so if I want C sub 1 is half of C sub 0 plus 80. What was C sub 0? If the initial concentration is 120. So C sub 1 is half of C sub 0 plus 80. Half of C sub 0 plus 80. And 120 micrograms per milliliter is C sub 0. We are adding 80, we get total of 140. What does it mean? It means for the next one class, okay, C sub 2, C sub 2, I want half of this. This is half of C sub 2, half of this, and then I add 80, okay, the inflow. Half of 140, 70, and we add the constant 80 becomes 150. Again, obviously, we are dealing with applications. We need to know the units micrograms per milliliter of the drug that is being used. What is the next one? I want C sub 3, so half of this, which is 75. And then we add 80. 75 and 80 is 155. So C sub 3 is 155. And what happens is as T gets larger, it's not going to go to infinity. That's important. That's why I want you to see why we want to sort of show the graph. And the graph, okay, flattens. And ultimately, you have what's called really the horizontal asymptote. You don't have to worry about that yet. It so happened that this concentration no matter what we do, the maximum is A as T goes to infinity in essence. A, which is AD, over K, which is 1/2. Division by 1/2, that means multiplication by 2. So 160 micrograms per milliliters. What does it mean? It means you can keep on giving the medication to the patient. It will never go beyond 160. Why is that important? Because based on the calculation that they have done, up to 160 is safe, and perhaps after that it's not safe. So I can't emphasize this enough. Okay, class? So that's dealing with patients and drugs, medication giving to patients. We'll look at this example. Anybody want to read this for us?
I can.
Please.
Just from the top, the whole thing, or just till A?
Please, the whole thing. I appreciate that. Thank you.
Example 6. Pacific salmon populations have discrete breeding cycles in which they return from the ocean to streams to reproduce and then die. This occurs every 1 to 5 years, depending on the species. Suppose that each fish must first survive predation by bears while swimming upstream, and predation occurs with probability D. After swimming upstream, each fish produces B offspring before dying. The stream is then stocked with M additional newly hatched fish before all the fish then swim out to sea. What is the discrete time recursion for the population dynamics, assuming that there is no mortality while at sea? You should count the population immediately before the upstream journey. Did I keep going?
Yes, please. I appreciate that.
Suppose that instead of preying on the fish while they swim upstream, bears do so only while the fish are swimming downstream. What is the discrete time recursion for the population dynamics? Again, assume there is no mortality while at sea. And which of the recursions obtained in part A and B predicts the largest increase in population size for 1 year to the next? Justify your answer both mathematically and in terms of the underlying biology. You can assume that 0 is greater than D is greater than 1, and B is less than 0.
Greater than 0. Thank you so much. Class D is the percentage, and it's between 0 and 1, and the probability is always between 0 and 1, so it's positive. The way they have it, it's not 0, it's not 1. and B is also positive. Let's just dissect this into pieces to make some sense out of it. We are looking at part A and part A only for now. To begin with, how much do we have? You can say X, you can say N, or we can say N sub T. It's fine. That means at time T, we have this much. So the very first thing that happens is the predation. So what happens? The probability of D, that means if the predation happens at 10%, that means 10% of salmons gone, the rest is left, okay? So 90% is left, okay? So whatever the amount of predation, the rest of it remains. Remember, it's a complementary event as far as statistics is concerned. So if 20% is gone, 80% remains. So 1 minus D times this number remains. Now, I've explained this one. We call this N sub T, N after the predation. You don't have to worry about that. This number, whatever you want to call it, X, Y, Z, N, times 1 minus D. Why 1 minus D? Because D is the percentage that is gone. Okay. What happens afterwards? Well, after the predation, there is B offspring before dying for each fish, okay? That means, simply put, multiply this one by B. If they didn't die, we would multiply by B and then add this number to it, in essence, B plus 1, but just B because they don't survive themselves, so simply times B, times B. So again, I'm just showing you this is N sub P, N sub P, we multiplied by B and we added, but the N sub P goes away. But just in short, you see this one? Multiply by B. What is the last step? We're gonna add, how many? M. So this is part A. We are adding this many, okay? We are adding this many. Now, part B is slightly different. Let's see what happens in part B, everybody. Okay, let's see what happens in part B. Now, part B, again, we start with the same number, N sub T, X, Y, Z, a variable of your choice. But this one, first, they produce B offspring. So first, multiply by B. Okay, so again, I'm explaining how we arrive at it, but just simply multiply by B. Because remember, when they give us the offspring, then they die. That's why you just multiply by B. And then we give it M more. So add M, add M, add M. Finally, predation takes place with the same probability of D. So if 10% is gone, 90% is left. So 1 minus D times this is left. Okay, 1 minus D times B times N sub T plus M is left. The last part is a comparison. Which one gives us more? So what I did, I put part A, the number that we get, and in part B, and we want to compare. Now, we're going to do this, and any ideas which one would give us more? Part A or part B will produce more fish? Well, I like to go over that mathematically first, because that is actually the proof, believe it or not. And then we discuss that, because you may have different ideas as to why the first one, okay, the predation happens first, the second one at the end happens, and you may have also sorts of, you know, justification, and that's fine and dandy. But let's prove that beyond the shadow of a doubt using the beauty of mathematics. How do we do that? We calculate A minus B. If it's positive, A is more. If it's negative, B is more. So let's write it. Part A minus part B. Now, in order for you to do this, you have two choices. Do the distribution one by one, very carefully write everything, subtract everything, and final answer. I am actually working it with a different method, which is factoring. That's why I'm showing this one minus this one. When you multiply this by this part, they cancel each other. So from the first fraction, m remains, from the first brackets, minus from the second one, 1 minus d times m remains, so minus that. Again, if you can't follow that, please just distribute and observe. So m from the first one, so if I factor it out, becomes 1. M times 1 minus d from the second one. So 1 minus 1 plus d, and it md. M and d, every number is positive, therefore m times d is positive. And if it's positive, that means part A minus part B is positive, part A is larger. Why is that? It makes sense. In part A, all additional fish survive, remember that. But in part B, all fish face predation. Because of that, part A gives us more fish.